Just remembered a friend's birthday? Simple. Send a quick email. Time was when you had to enroll in an institute to do this. First generation computers made around 1940s used vacuum tubes as their circuits and magnetic drums for memory. This meant that they were huge cumbersome devices available only at institutes and offices. The second generation of computers involving transistors were somewhat smaller. It was only the third generation that found its way into homes. That is because here the transistors were made so small that they could be placed into one special chip known as ICs or integrated circuits. What were those special chips made up of? Let's find out in today's episode. Hi, I am Devabrata Goswami. Let's explore the contribution of chemistry to modern life. We will study about silicon, its important properties, and various compounds of silicon like silica. Furthermore, we will study the types and structure of silicates, preparation and properties of silicones, and then, of course, clear your doubts in our exam decoded section. Silicon is a shiny blue-gray nonmetal. It is the second most abundant element, making about 25.7% of the Earth's crust by mass, and is found in the form of silica and silicates. 95% of Earth's crust is made up of silica and silicates. It is also the element I was talking about in the beginning of the episode, the element that made the dream of compact, efficient computers come true. Silicon is an important constituent of silicones, a class name for various synthetic plastic substances made of silicon, oxygen, carbon, and hydrogen, often confused with silicon itself. Silicon is used to strengthen aluminum alloys for aircraft. Its semiconducting properties are also used in transistors and solar cells. An important fact about silicon is that it shows semiconducting properties even at high temperatures. This brings me to the answer of the question I had asked you earlier. What was the element that revolutionized computer science? Well, it was silicon. The size of the transistors were made so small so that they could be placed onto one special chip, which is a silicon chip. The use of silicon chips made computers compact and efficient. Third generation computers started the use of keyboards, mouse, monitors, and other interfaces rather than the punched cards. Computers for the first time became accessible to a mass audience because they were smaller and cheaper. So what are the forms in which this wonder element is found? Well, the principal oxide of silicon is called silica or silicon dioxide. Silica, which chemists would call silicon dioxide, is widely found as sand and quartz. Silica is used in inexpensive soda-lime glass, which is common and typically used to make drinking glasses, bottles, and windows. Silica is also used in manufacture of ceramics as well as mortar that forms an important construction material when mixed with lime or cement. Well, quartz is extensively used as a piezoelectric material, that is, the materials that produce electrical charge when mechanically stressed. But do you know that it was quartz that made it possible to develop these extremely accurate watch, modern radio, television, broadcasting, and mobile radio communications? The colored varieties of quartz are also used as gems such as rose quartz, rutilated quartz crystal, smoky quartz, jasper, amethyst, and opal. The opaque quartz is used in making vessels which are acid and alkali resistant and can withstand sudden changes of temperature. To help you understand better, let's take a look at the structure of silica. Silica, or SiO2, has a three-dimensional network solid structure. In this, each silicon atom makes covalent bonds in a tetrahedral manner with 4 oxygen atoms. Each corner of this tetrahedron is shared with another tetrahedron. The entire crystal may be considered to be a giant molecule in which 8 member rings are formed with alternate silicon and oxygen atoms. Besides silica, silicon exists in the form of silicates. Silicate minerals compose a large percentage of the Earth's crust. Silicates are complex network solids. Their basic structural unit is the silicate ion. The shape of the silicate ion is tetrahedral. Here, the silicon atom is bonded to 4 oxygen atoms present at the corners of the tetrahedron. Till now, we learnt about silicon, its oxides, and their structures. Before moving further, let me ask you a question. Why is industrial region around the southern shores of San Francisco Bay, California, known as Silicon Valley? The answer to this question, as usual, after a short break. Meanwhile, you can log on to www.topperlearning.com for more information on this topic. Hi, I am Deobrata Goswami and you are watching Chemistry 11. Today we have been talking about silicon. Before the break, I had asked you, why is industrial region around the southern shores of San Francisco Bay, California, known as Silicon Valley? And here is the answer. Its name is derived from the dense concentration of electronics and computer companies that have sprung up there since the mid-20th century. Silicon being the base material of the semiconductors employed in computer circuits. Moving further, in silicates, either the discrete unit is present or a number of such units are joined together via corners by sharing 1, 2, 3 or 4 oxygen atoms per silicate units. Therefore, silicates are classified on the basis of the manner in which the silicate tetrahedron units are linked together. Let us study them one by one. A silicate which contains a simple silicate ion in which all the oxygen atoms are bonded to associated metal ions are called orthosilicates. In orthosilicates, the silicate ion SiO4 4- does not share any corner with another silicate ion. An example of orthosilicate is olivine, a gemstone that is green in color. The formula of olivine is Mg(Fe)2SiO4. Moving on to the next type of silicates, which is pyrosilicates. They are obtained when 2 silicate ions share 1 oxygen atom. The general formula is Si2O7 6-. This type of structure is known as island structure. Chain silicates are formed when 2 oxygen atoms of each tetrahedron are shared with other tetrahedron in a linear chain. They form linear chains and have a general formula SiO3(N)2N-. Next type of silicates is cyclic silicates, in which 2 oxygen atoms of each silicate unit is shared with other silicate units. The general formula of cyclic silicates is SiO3 whole N 2N minus. If two oxygen atoms per tetrahedron are shared, ring structures may also be formed. These are called cyclic silicates. They also have the general formula SiO3 whole N 2N minus. These kinds of cyclic silicates with 3, 4, 6 and 8 tetrahedron units are known. Some of you who are inquisitive by nature must be thinking, if there is any real-life example of cyclic silicates. Well, yes, beryl is one such example. It is a typical mineral having cyclic silicates. Different varieties of beryl have been considered as gemstones like emerald and aquamarine. Now, let's look into another category of silicates, that is sheet silicates. Sheet silicates are formed when 3 oxygen atoms at corner of each silicate tetrahedron units are shared. An infinite two-dimensional structure is formed. Clay is an example of sheet silicates. So that was about different silicates. Next, we will consider silicones, which are organosilicon polymers. They contain R2SiO units, where R stands for alkyl or aryl groups. The name of silicones is analogous to ketones. Silicones can be linear chain, cyclic or cross-linked. They are formed depending on the starting substance used for polymerization. Let us see how silicones are prepared. The starting materials for the manufacture of silicones are alkyl or aryl substituted chlorosilanes. These are prepared by the reaction of alkyl chloride with silicon in the presence of copper as catalyst at a temperature of 570 Kelvin. In this way, various types of alkyl substituted chlorosilanes are formed, which have the formula RSiCl3, R2SiCl2, R3SiCl with small amount of R4Si. On hydrolyzing alkyl or aryl substituted chlorosilanes, the chloro group is substituted by hydroxyl group. For example, dichlorodialkyl silanes on hydrolysis yield dialkyl silane diol. Straight chain silicones are formed by condensation polymerization of dialkyl silane diol. The chain length of the polymer can be controlled by adding trimethylsilyl chloride, CH3 whole thrice SiCl, which blocks the ends. Silicones are resistant to heat and many chemicals. They have various uses in daily life. They are used in water-repelling fabrics like raincoats. Silicones are also used in making hearing aids. But the shortcoming of silicones is that they are quite expensive. So that was about silicones. Right now, we have a young caller with a query.
Hello sir, my question for you is, why do silicones have water repelling properties?
Good question. Well, silicones are water repelling in nature because of the presence of nonpolar alkyl groups. They are also used as sealants by aquarium manufacturers in order to join glass plates to make aquariums of every size and shape. Glass joints made with silicone sealants can withstand hundreds of metric tons of pressure, thus making the original aquarium construction method of using angle iron and putty obsolete. If you have further doubts and need practice questions to solve, you can log on to our website www.topperlearning.com. I am sure it will be a great helper for you. I will take a short break now. We'll be back in a while with Exam Decoded. Welcome back. I am Deobrato and today we are trying to explore the silicon world. Before moving over to exam decoded, let's do a quick recap. In this episode, we learned that silicon is a shiny blue-gray non-metal with semiconducting properties. Today, we also studied about the various compounds of silicon, including silica. Silica, also known as silicon dioxide, is a three-dimensional network solid in which each silicon atom is covalently bonded in a tetrahedral manner to 4 oxygen atoms. Then we studied about silicates, which are complex network solids with the basic structural unit silicate ion SiO4 4-. Silicates are classified on the basis of the manner in which the silicate tetrahedron units are linked together. And now it's time to exercise your gray cells. Yes, I'm talking about exam decoded. Welcome to exam decoded. Let's bring that exam related stress to an end and play our rapid fire round. I will give you 5 questions and you have only 5 seconds to answer. And remember, for each correct answer, you will be awarded 1 point. First question. What is known as an organosilicon polymer? A. Silicates, B. Silica, C. Silicon, D. Silicone. The correct answer is D. Silicone. Now for the second question. Beryl is A. Orthosilicate, B. Pyrosilicate, C. Cyclic silicate, D. Chain silicate. The answer is C. Cyclic silicate. Moving on to the third one. The basic structural unit of silicates is A. SiO4 4-, B. SiO4, C. SiO2, D. SiO4 2-. If you had selected A, your answer is right. Next, silicon has semiconducting properties. True or false? True, and that makes it suitable to be used in computers and solar cells. The last question to test you is, SiO2 is a three-dimensional network solid. True or false? The correct choice would be true. Now, let's see how you fared. If you got all 5 questions right, you are a high flyer. Great going. Your concepts are clear and you applied them well. If you got 4 or 3 right, then we will call you an achiever. A little more focus can get you on the top. But if you got 3 or less, you need to go through the topic once more and see where you are lacking. For more help, you can always log on to www.topperlearning.com, where you will find all we studied today and a lot of questions for practice. The topic Silicon and its compounds is from the unit The P block elements. The weightage of the chapter is 7 marks and therefore it is critical from exam point of view. Usually 2 or 3 marks short answer type questions are asked from this topic based on knowledge ability. This makes this chapter fairly high scoring. Now let's see a sample question and the ideal way to answer it. What are silicates? Explain and draw the structure of silicate ion. This question can come in your exams for 3 marks. This is how you should answer it. Silicates are complex network solids with silicate ion SiO4 4- as the basic structural unit. The definition will fetch you 1 mark. The shape of the silicate ion is tetrahedral. Here, silicon atom is bonded to 4 oxygen atoms which are present at the corners of the tetrahedron. Explanation of the shape will fetch you 1 more mark. Next, explaining correct tetrahedral structure with the help of a diagram will fetch you the last 1 mark. That was all about silicon. which is also called the element of the 21st century. It's time now for me to go, but let me leave you with some food for thought. Do you know which kind of compound is used for cosmetic and surgical implants and why? I am sure you can guess the answer, but do log on to www.topperlearning.com to confirm it. Keep thinking. This is Devabrata saying goodbye.